Hi everyone, today I'm talking about the Dijkstra algorithm, which is an algorithm to find the best path between an origin and a destination. So I have here a network, as you can see. For this network I have a set of nodes, A, B, C, all the way to H. I have a set of links that connects those nodes, and I have also here an impedance, right, which is the cost to traverse that link. Okay, now the cost is the same to go from A to B or B to A, it's 20 here. So here I have to think about what is my origin. I'm going to say my origin is A here, okay, and let's say my destination here is H. Okay, so the question is, what is going to be the best path to go from A to H? And we are going to use the Dijkstra algorithms, who he was actually a Dutch mathematician. He came up with a really good paper, you can check it out. Essentially, it relies on three approaches here: scanning which nodes are available from a starting node, estimate the cost to reach to those nodes, and then update the cost and also update the node where you're coming from. Okay, so let's do a first step here together. I'm going to take another chalk. Okay, this one, and I'm going to start with A. So with A here, so this is step number one. From A, where can I go is a non-stop. Remember, we talked about non-stop before. I can go to B, I can go to D, and I can go to F. So how are we going to write this? We are going to write for F here, right? We're going to say to go to F, I can go from A, okay, and the cost to go is going to be equal to 7. Okay, that's good. Okay, similar, I can go to D. So to D, that's going to be A, right? That's the original node, and it's going to take me 15, cost of 15. And similarly for B, I can go to B, coming from A, okay, and this is going to take me a cost of 20. Okay, so this is where I have scanned from A, which node can I go in a non-stop, and then adding here what the cost is going to be. Now for the others, we don't have anything. We can't get to C, we can't get to E, we can't get to J, we can't get to H quite yet. So we don't know what the cost is going to be. That's the first step. Now let's look at the second step. Okay, we have done our first step, now let's go into our second step. So I look from here and I'm asking myself, which node is the most promising? And how to define the most promising? It would be the node that has the least amount of impedance so far, and that will be F. Okay, so what I'm going to do here, I'm going to leave this as is, and I'm going to recalculate, right, what is the cost. So from F to all of the other nodes that can be accessed. Now we're not going back to A, okay, but we're gonna go back, we can go back to D and we can go to J. So let's go and do J here. So J is going to tell me the following. So J is going to tell me, it's going to take me 7 plus 20, so that's 27, and I'm coming from F, okay, F 27 here. Okay. Now, from F, I can also go to D, right? And 7 plus 5, how much is that? That's 12, right? So I'm going to update this. Now, this doesn't take a long time. Here, I'm going to update this one. I'm coming AF, so I'm coming from F, and the cost here is 12. So you see, we're doing better, so we update that, actually. Now, we're gonna go to the third step right now. We are now at our third step. So what we have seen here, we have seen what is the most promising. So we have done this one, right? So F here, no need to go to do more. We have, because we have scanned everything from F, so F is done. D as a 12 and B as a 20. So what is the most promising node at this stage is going to be D. So from D, we're going to scan where we can go. Okay, so the first place where we can go is from D, we can go to J here. So 12 plus 13, that's going to be 25. So that is better, right? So I'm going to change this because it's better. And I'm going to say that to go to G here, or J, sorry for the pronunciation, that would be 12 plus 13. So that would be 25 here. Okay, Adrian, please. That would be from D right there. Okay, that was my son playing some game. So that's good. From D, I can go to E here. Okay, so to get to E here, what I'm going to write is that I'm going from D, and the total cost is going to be 12 plus 14, so that's going to be 26 right here. Okay, thank you. And then from D, I can go back to B. Is this any better? So 12 plus 6, yes, 12 plus 6, how much is that? That is 18. And so I can change this one to Okay, so D here and then here 18. So this is of course better, and I think that's all I can do. So the next step will be what is the most promising node, and that will be, so this one is going to be B right here. So we're gonna get and do that one. Okay, we are now at our next step. So the next question was, which node is the most promising at this stage? So again, I'm looking at what is the lowest possible value here, and this would be B here with a value of 18. So from there we can compute then what is the value. So from B now I can reach C, right? That's an option, of course. And I'm going to write here, so that will be then B, right? Okay, and from there 18 plus 15, that would give us here 33. Okay, very good. So from B I can go to E. Now 18 plus 9, that would be, for me, that would be 27. Is it better or not? So 18 plus 9, 27. Is it better? No, it's not better. Okay, and again, that's all I can update. So this is where I am now, and we are going to go to the next step. Okay, so now we are again at the next step. What nodes are the most promising? Not this one maybe. Now this one is the most promising. So from here I will compute the travel and estimate. So from J I can go to E. Is it any better? So 25, 40. No, it's not better than this. And from J I can also go to H. So 25 and 20, that would be here. How much? 25 and 20, 45. So from J, 45 here. So we do have a solution, a feasible solution, but we don't know if it is the best. So now that we have checked this one, okay, that we have checked the B as well, we're going to see what is the most promising, and that would probably be this one next, and then we also will do this one afterwards. Okay. So here from E, what can I calculate? Because this would be the next possibilities. From E here, I can add a value of 8 to go to H, so 26 and 8, that would bring us to here 34. So here this changes, right? And this would become E here 34. Very good, much better. Okay, from E I can add 6, 26 and 6, so that is better. Okay, so no, that becomes here E, and to this, sorry, here E, and to this 26 and 6, that would be 32. Okay, that would be the solution here. Now, as you can see, I've almost exhausted all the nodes. If I want to go from C to H, that's 32 and 12, that's 44. Is 44 better than 34? No, it is not. Okay, so now that I have reached all these steps, the very last part is to draw then what is the path. So starting from H, I see I come from E. From E, I see I come from D. From D, I see I come from F. From F, I see I come from A. And so that is your path, the optimal path. A, F, D, E, H, as you can see right there. So that sort of summarizes the Dijkstra algorithm. I know there are better probably ways to show it and probably a better algorithms, but that would be kind of the sort of dirty way to do it by hand, okay? And we can check later on to see whether or not the solution that we obtain is the optimal one.